Hello, my name is Jen Langer, and I'm the ArcPad Product Manager with ESI in Redlands. Joining me today is Shane Clark, another Product Manager of ArcPad from ESI Olympia office. We would like to welcome you to the live training seminar on working with ArcPad 7. In today's seminar, we will discuss three main topics. First, we'll cover the overview of ArcPad, its workflow, and new enhancements in ArcPad 7. Then, we will provide an overview of ArcPad interface and out-of-the-box functionality. In the last topic, we will discuss some general principles and tips on using ArcPad. We will conduct two software demonstrations and have review periods followed by a question and answer session. During that session, Shane and I will answer some of your questions. So let's get started with our first topic, the overview of ArcPad 7. Before we start talking about the specifics of ArcPad, we need to understand the bigger picture first. What is mobile GIS? Mobile GIS or field GIS is taking your GIS data from the office into the field using mobile devices. It enables mobile workers to display, capture, and analyze geographic information in the field. Mobile GIS is a growing technology, and more choices are becoming available. It integrates several technologies, including a broad range of mobile devices, GPS positioning system, field GIS software, wireless connectivity to access real-time information, and integrate sensors such as digital cameras and RFID scanners to record descriptive feature attributes. So, what is ArcPad? ArcPad is ESI software for mobile GIS and field mapping applications using handheld and mobile devices. ArcPad supports numerous devices from tablet PCs to Windows Mobile PDAs. With ArcPad, you can integrate GPS, rangefinders, and digital cameras into GIS data collection. ArcPad includes out-of-the-box functionality to display, capture, and analyze GIS data in the field. ArcPad is easily to customize to your specific applications with or without programming. The enterprise ArcGIS data can be shared with field workers using ArcPad for updating and decision-making. Therefore, ArcPad is part of the enterprise ArcGIS solution. ArcPad is designed for organizations wanting to expand the benefits of GIS from the office to workers in the field. It is used by a variety of field workers, including firefighters, police officers, utility workers, inspectors, military, and biologists, and more. Applications include field mapping, asset inventories, asset maintenance, inspections, and incident reporting. The recommended ArcPad workflow is to first design the geodatabase schema in ArcGIS and then use ArcGIS Desktop to extract data from the geodatabase, either features or template schemas for editing in ArcPad. The next is to perform the necessary data edit in the field with ArcPad, and finally, update the geodatabase with the ArcPad edits. Traditionally, paper maps are what used in the field by mobile workers. Field edits were performed using sketches and notes on these paper maps. Once back in the office, those field edits were then manually entered into the GIS database. The ArcPad workflow, as outlined before, has enormous productivity gains. It eliminates the major portion of office work previously required. More importantly, it improves the accuracy of the field GIS data, resulting in a more accurate and current database for analysis and decision-making. This is a major benefit of mobile GIS applications. ArcPad 7 is a major ArcPad release. It offers enhancements in the area of performance, including quicker access and loading of spatial data. New advanced editing tools, including offsets, repeated attributes, segmented line features, snapping, and undo. ArcPad now supports rangefinders and digital cameras. It also supports ArcGIS symbology and style sheets and has more labeling options. Maps in ArcPad 7 look the same as in ArcMap. Using the newly available graphics layer, you can now take notes on maps in the field. ArcPad 7 includes additional tools for ArcMap, which are automatically installed with ArcPad installation. These new tools allow you to extract data, including symbologies, for use with ArcPad 7. In the area of customization, you can now create simple custom forms within ArcPad. Let's go to our first software demonstration. Both of our demos today will use data from a city in the United States. The purpose of our first demo is to demonstrate an out-of-the-box solution to extract data from the geodatabase for editing in ArcPad. Here we're looking at an ArcMap document in ArcGIS Desktop. It contains data layers of electrical lines with meters, an inspection polygon, and an aerial photo of the city. Our task today is to do a field inspection of the electrical network. Here is the ArcPad toolbar for ArcGIS. Using the Get Data for ArcPad 7 tool, we want to select all the data layers that we would like to copy to our mobile device. Next, we specify the layers that we will edit in the field. Then we specify the output folder and check that we would like to only extract data within the current display extent. Now the data are being extracted from the geodatabase with the selected features are exported to shapefiles. The next step is to use ActiveSync to synchronize the data to the field device. For the purposes of the demonstration today, we will use the ArcPad on the desktop here. Once the extracted data are copied onto the field device, I will use ArcPad to open the ArcPad map document created for us by the extracting tool from ArcGIS Desktop. Okay. Now, the first thing you'll notice is that the symbology, as well as the data, are extracted from the database, from the geodatabase. The map in ArcPad look the same as in ArcGIS Desktop. Sometimes, however, Some of the symbols which work well in the office may not work as well in the outdoor environment. For example, for the inspection layer, the color for the fallen trees and trees need trimming look almost identical under the direct sunlight. ArcPad gives you the capability to change the symbology in the field. I'm going to change the trees need trimming and select a more distinguishable color. During the inspection, I noticed an area right here where the trees need to be trimmed. If I have my GPS receiver, I can walk along the area and record this inspection area. Now I start digitizing. As I finish digitizing, I see this custom input forms. This is created automatically by the checkout data tool from ArcGIS desktop. The domains and subtypes in geodatabase are exported here to this custom input form. I'm going to select the attribute trees need trimming here. There, I finished digitizing my first inspection polygon. Also during the inspection, I noticed that there are some new electrical lines being added in the area. Next, I'm going to digitize the electrical lines. Again, the subtypes and domains defined in the geodatabase are exported automatically to this custom input forms as a pick list. The last thing I'm going to add is the electric meter. There, I finished the inspection work of the day. The next step is to use ActiveSync to copy the field edits to the synchronized folder on the desktop. Now back in the office, I would like to check in the field edits I made in ArcPad into my geodatabase. We use the simple check-in tool to do that. Notice that the features I added in the field are now being updated in the geodatabase. Also, the symbology I defined in ArcPad for visibility purposes does not affect the symbology used in ArcMap. In this demo, we showed an out-of-the-box solution for extracting data from a geodatabase for editing in ArcPad. Domain and subtype rules are exported to custom forms, which enforce attribute integrity when capturing data in the field with ArcPad. We also use the simple check-in tool to update the geodatabase with the ArcPad field edits. In this section, we went over mobile technology and discussed features and benefits of ArcPad. We also talked about the recommended ArcPad workflow, and finally, the new enhancements in ArcPad 7. I will now turn the seminar over to Shane, who will answer some of your questions.
Thanks, Jan. First question comes from Misama in Newmarket, who asks, does ArcPad 7 support data checkout check-in workflow with SDE? The checkout check-in tools only work with geodatabases, either personal geodatabases or enterprise geodatabases. So if these geodatabases are managed through SDE, then the tools will work with those. The next question comes from Matt in Medina, who asks, I noticed you have an aerial photograph in your example. Is there a size limitation to how large the photo can be, either file size or dimensions when extracting the data from ArcGIS desktop? Yes, there is a file size limitation, and this limitation is approximately 17 megabytes for the image that is extracted from the screen view. The easiest way to determine whether you've reached this limitation or not is to use the tools in ArcGIS Desktop to export the current viewed image to a TIFF image and view the size of that TIFF image. If it is over about 17 megabytes, it is too big. The next question comes from Steve from San Diego, who asks, what is meant by integrated sensors? Integrated sensors is a term that we use for a wide variety of input devices. These devices may be built into a mobile device, or they may be connected by some form of serial communication. And these devices include GPS receivers, laser rangefinders, water meters, any device which is sending data to your mobile device. The next question comes from Jenny in Seattle, who asks, can ArcPad capture Z values from a GPS? And the answer is yes. ArcPad does capture the Z values coming from a GPS position, with the condition that the shapefile that you're capturing the data into is defined as a Z shapefile. With that, I'll hand back to Jane.
Thanks, Jane. Now let's talk about some of the out-of-the-box functionalities in ArcPad 7. The first step is to prepare data for the field. There are several options to prepare data to be used in ArcPad. You can create new shapefiles in ArcPad, and in ArcPad 7, you can use the quick form to create custom input forms. This ensures that data is captured accurately in the field. You may also add existing shapefiles and various image formats to ArcPad. As we've seen in the previous demo, using ArcPad tools for ArcGIS, data can be extracted from geodatabase for editing in ArcPad in the field. For faster performance, we recommend you to extract the appropriate subset of data and use shapefile indices and scale-dependent symbology. The ArcPad tools for ArcGIS toolbar provides some of the tools for preparing data for use with ArcPad. The Get Data for ArcPad 7 tool lets you extract data from your ArcGIS database to a checked-out folder, which then can be uploaded to a mobile device. The checked-out features are converted into shapefiles for editing in ArcPad. As we saw in the demo, the ArcPad tools in ArcGIS automatically create custom input forms using the domains and subtypes defined in the geodatabase to generate pick lists. ArcPad 7 supports most of the layer properties and symbology supported by ArcGIS Desktop. ArcPad supports a multi-layer environment with industry-standard vector map and raster images. In addition, ArcPad can act as a client to ArcGIS, ArcIMS, or to the geography network. ArcPad has a number of map navigation tools, including pan, zoom, spatial bookmarks, and map rotation. ArcPad provides the tools to query your data to solve problems and retrieve information directly in the field. With ArcPad, you can uncover information about features by tapping on them. You can display additional information about features that hyperlinks to pictures, video, or voice recording. You can locate a feature within the extent of your map, label it, and zoom to it. You can find features by attribute query and measure the distance between features and determine the area of a polygon feature. In addition to displaying and querying data, ArcPad allows you to capture and edit spatial data, including points, lines, and polygons. ArcPad includes editing tools for offsets, repeated attributes, segmented line features, snapping, and more. By editing a graphics layer, you can record field sketches and nodes. These sketches can become part of the geodatabase and be shared and exchanged to and from ArcGIS Desktop. Using the incoming GPS coordinates, you can capture point, polyline, and polygon features. You can also move existing points and vertices to current GPS position. The GPS position window is used to display information about GPS satellites, GPS position, as well as navigational information. ArcPad includes a number of user-specified options that can be used to control which of the incoming GPS coordinates are used. For example, the quality options allow you to specify the maximum PDOP value. You can use these options to ensure that ArcPad only uses those GPS coordinates that meet your accuracy requirements for data capture. When you activate a GPS track log, ArcPad automatically records each GPS position it receives as a point feature in a shapefile. Other data capture devices, including rangefinders and digital cameras, are also supported in ArcPad. A rangefinder provides an accurate offset to pinpoint desired features that are not accessible. Rangefinders provide offset measurements, such as distance, bearing, and inclination. In ArcPad, when a rangefinder is connected and activated, the measurements are automatically transferred. Digital cameras is also integrated with ArcPad. From within ArcPad, you can control the connected camera by previewing the image, then taking the photo. A digital photo can be linked to the actual location where the photo was taken and associated with descriptive attribute information. These photos become part of ArcPad project and can be accessed through hyperlinks to features. Digital photos, which have GPS coordinates embedded in the standard EXIF header of the image, can also be displayed on ArcPad map as a photo layer. One of the new features in ArcPad 7 is the support of offsets. Now let's take a closer look of working with offset. Offsets are used when the object you would like to map is difficult to access or dangerous to occupy. For example, you may wish to map a manhole in the middle of a busy street. It is also used because GPS is not always the most effective means for data collection. The situations where GPS has been least effective have been locations where the view of the sky is obstructed, such as under very dense trees, or in locations where most of the sky is blocked by buildings, such as in the urban downtown area. Additionally, a GPS receiver is designed to compute the location of its antenna. This means in order to capture that location, you have to go to that location. As what we mentioned earlier, it is not always practical to physically visit the location of every object that you wish to map. There are two types of offsets in ArcPad, simple and complex. A simple offset is performed on a polyline or polygon and only uses the distance measurements. Using a simple offset, you would map a feature that is a constant distance away from a polyline captured via a pen or GPS. You would also specify whether the new feature is left or right of the captured polyline. For example, you could map the distance of a new sidewalk to the left of and at a distance of 5 meters from the center of an existing road. Complex offsets can be used for point features and vertices of polylines and polygons. Complex offsets use a combination of distance, bearing, and inclination measurements. ArcPad supports one-point offsets and two-point offsets. A one-point offset uses distance and bearing measurements to determine the offset. The reference point can be set by GPS or pen or manually input coordinates. If your application requires elevation data, please make sure that the system you purchase can provide inclination and that you're storing your results in a shapefile that supports a z-value. A two-point offset is based on two reference points. Again, the reference points can be set using pen, GPS, or manually entered coordinates. There are two variations available in ArcPad for the two-point offset. The first one uses two distance measurements. Note that the distance or solution requires that you specify which side of the AB line the offset point lies. With the rangefinder active, the fields are automatically populated. The second variation of the two-point offset uses two bearing measurements to calculate the offset. This is used when two bearings are known from the reference points, but distances are not. Traverses in ArcPad enable you to create polylines and polygons using offsets. In ArcPad, there are two types of traverses. A linear traverse enables you to capture the vertex of a polyline or polygon from a known point as you walk along a traverse. For example, you may use linear traverse to capture a path under a dense canopy where GPS signals are blocked. With a linear traverse, your reference point is always the last point you captured. A radial traverse uses one fixed reference point and creates a traverse relative to the fixed point. In other words, you are always standing at the same fixed point while capturing multiple vertices. Once you are complete with the field edit, you may want to check in updates you made in ArcPad to your GIS database. This is done using the check-in tool in ArcPad Tools for ArcGIS. You also have an option to remove unwanted checkouts from the transaction log. Now let's go to our second software demonstration. In this demonstration, we will revisit the city from our first demo. In our previous demo, we had added a secondary electrical line in the field. Now if we zoom into the line we added, you can see that the secondary line is not connected to the main electrical line as the way it's supposed to be. If we zoom to the meter we added, it's also not connected to the electrical line where it should. Using the snapping capability in ArcPad 7, we can ensure that those lines are connected correctly. First, we'll set our snap tolerance to be 15 feet. Then we'll turn on the snapping for the layer of secondary line. Now we'll redigitize those lines and meters. First, we'll add the secondary line. Finish the attribution. Then we'll add the electric meter. Now if we zoom into the line we just digitized, as you can see, it snapped correctly to the main electrical line. Same goes for the meter, which connects correctly to the vertex of the secondary line. By pressing the Control key on the desktop, you can see your snapping buffer. The same thing can be done on your mobile device by pressing the Center key. You may also remember that in our previous demo, we had added an inspection area where trees need to be trimmed. Instead of walking along the area to record the inspection polygon, we can also use a rangefinder and using the offsets and radial traverse to capture the inspection polygon. First, I'm going to set my reference point, which will be the point I'll be standing. I'll select this cul-de-sac. And then with my laser rangefinder, I'll start taking measurements. The rangefinder returns the distance and bearing to calculate the offset point. I'll continue taking on the measurements until I'm done. Now I put the attributes. Now I finished digitizing the polygon by standing at one fixed point using my laser rangefinder and radial traverse to digitize the inspection polygon. The last thing I would like to show here is to use graphics layer to capture field notes and sketches. I'll first add a new graphic layer. Call it inspections. In ArcPad graphics layer, you can store text, points, polygons, and polylines. Actually, lines. So I would like to mark the area that I would like to come back to inspect later. So I'm going to use the freehand line tool. And then add some text. Set the text symbol, color, now as you see, I added a field note on my ArcPad map. This graphics layer can be easily imported into ArcGIS and then be shared with other users as well. In this demonstration, we showed some ArcPad editing tools using GPS, pen, or rangefinders. We use snapping to ensure correct connectivity of features, and graphics layer to add some field notes. In this section, we discussed some of the ArcPad out-of-the-box functionality. We talked about preparing data for ArcPad, displaying data, and querying data. We also talked about the data capture and editing functionality in ArcPad, including working with offsets. We covered the use of data capture devices, such as GPS, rangefinders, and digital cameras. Finally, we covered how to check in the ArcPad edits to your GIS database using the ArcPad tools in ArcGIS Desktop. I will now turn the seminar over to Shane, who will answer some of your questions.
Thank you, Joan. The first question comes from Brent and Lindsay, who asks, can the snapping buffer be altered? Yes, you can change the snapping buffer at any time. However, the new snapping buffer that you've set will only be used for new features that you add or edit. They won't be changed retrospectively for existing features that you've added or edited. The next question comes from John in Fort Myers, who asks, does ArcPad need one geodatabase to extract all data from in a single project? Or can multiple geodatabases be extracted from and updated on a single project? You can extract data for reference data from multiple geodatabases. However, you can only extract data for editing in ArcPad from a single geodatabase. DeRay from Mountain Home Air Force Base asks, when making field edits, if you just make attribute changes only with no new features, do these come through as well? Yes, these edits do come through. When you have checked out data from a geodatabase for editing in ArcPad and you edit in ArcPad, you can edit either the geometry or the attributes or both of these, and all of these edits will be updated to your database when you check the data in. Brent from Richmond Hill asks, is there a ratio between increasing the PDOP value and the resulting decrease in accuracy? In other words, if you increase the PDOP by 1, does the accuracy decrease by, say, 1 meter? In practical terms, there are many factors that impact the accuracy of your GPS position. PDOP is just one of them, and often may not always be the most significant issue. The quality of your GPS receiver, the size of your antenna, the troposphere conditions, if you've got multipath rejection, if you're working under canopy, all of these are variables that impact your accuracy. So going just by PDOP is not a sufficient indication of accuracy. Gary from Orlando asks, can ArcPad symbolize per subtypes, or is it only one symbol per shape? When you extract the subtypes from a geodatabase for use in ArcPad, these subtypes are not stored as attributes associated with the shapefile. They are stored as part of the custom input form. So you cannot in ArcPad symbolize on the subtype, you can only symbolize on the attributes that are actually stored in the current shapefile. Secondly, you can only symbolize an ArcPad on a single attribute per symbol or per shape. Two more questions. Ruth Ann from Merced asks, what aerial photography file types does ArcPad 7 support? ArcPad 7 supports a wide variety of image types, including Mr. SID, both Generation 2 and Generation 3, JPEG 2000, TIFF, including a wide variety of compression formats that are included with TIFF images, PNG, JPEG, bitmap, and CADRG. David from Gainesfield asks, does ArcPad support image catalogs? And the answer there is no, it does not. And lastly, Vlad from Portugal asks, can I use toolbars or maps created with ArcPad 6 without any limitations in ArcPad 7? And the answer to that is yes. Apart from some minor issues that will rarely be encountered, the toolbars, the customization that you created in ArcPad 6 is supported in ArcPad 7. However, bear in mind that ArcPad 7 supports a richer set of symbology and functionality. And so in order to take advantage of these, it's really recommended that you regenerate your maps for use in ArcPad 7 that takes advantage of the new symbology support. With that, I'm going to hand over back to Jen.
Thank you, Shane. Now, in our last topic, I would like to briefly offer some general suggestions and tips on using ArcPad. Here is a list of questions you should ask yourself when planning a mobile solution. Who is the end user? What field environment will you be working in? Under what conditions? Vehicle-based or not? Is customization needed? What data will be required? What's your budget? Responding to this assessment will help determine your specific requirements for hardware, software, and support, and will influence your development timeline as well as required resources. Here are some device-specific considerations. By examining your application needs and requirements regarding device weight, size, speed, battery power, and operating system, you will be able to select hardware that is most suitable for your specific project needs. For example, if your application is vehicle-based, that the field workers spend a short amount of time away from the vehicle, tablet PC may be an ideal device to use. In these applications, device weight, size, and battery life are not an issue. However, if your mobile.js application requires field workers to spend a lot of time walking, the tablet PC will not be a suitable device, because in this case, the device weight, size, and battery life are an issue. We suggest that all users should customize their applications. You should use input forms to ensure data integrity. Using customizations can also help to improve usability to fit your specific application and to automate tasks and add new functionality. Customization in ArcPad is simple to accomplish. Users can create custom forms directly within ArcPad while in the field. No programming is required. If necessary, the developers can create more advanced ArcPad customizations in the office using the ArcPad application builder. Here are some tips for working with ArcPad. Some of them we had already covered in our previous topics. Please keep in mind that ArcPad is a mapping tool for working with your GIS data in the field. Your field devices generally have relatively slow CPUs and limited RAM and storage capacity and also a smaller display. Please take these into considerations. We also recommend you to use custom forms and toolbars in your ArcPad applications. They're simple to do and ensures the quality of your field data collection. In this section, we covered some general principles and tips of using ArcPad. A list of questions you should ask yourself before starting your mobile application, considerations to find a suitable hardware device, and finally, we will recommend you to use customizations to ensure the accuracy of the data you capture in the field. I will now let Shane answer a few more of your questions.
Thanks, Jan. First question comes from Brian in Tumwater, who asks, is it possible to select multiple types for a feature? The screen appears to allow only one. I presume by this question that these types are the pick lists or drop-down lists from the custom forms. And the answer to that is each attribute field can only store a single attribute string. So when you're only able to select a single type for each attribute field for a feature. The second question comes from Richard in Lexington, who asks, after creating a point, a set of options appear that allow specific information to be defined. In other words, these pick lists and selections in your custom input form. Was this customized with an ArcPad or an application builder? And the answer in this specific demo, the answer is neither of these were used. Although you can use ArcPad, the quick form tool that's available with an ArcPad to create some custom input forms, or you can use ArcPad Studio, the application that's included with Application Builder, to create more advanced custom forms, as well as more advanced customization. The forms that you saw in the demo were not created using either of these. These forms were created automatically from the checkout tools in ArcGIS. And in this case, you do not need Application Builder. William from North Charleston asks, does snapping work when using a GPS? And the answer is yes. If you have snapping enabled, the GPS coordinates that you're receiving from the GPS will then be snapped to existing features. Obviously, if you are using a GPS and you have snapping enabled, you need to determine whether you want the absolute coordinates from the GPS or whether the existing coordinates of existing features overrides these GPS coordinates. The next question comes from Brian in Tumwater, who asks, when do you perform differential correction? There are two types of differential correction. The first is termed real-time differential correction, and this is done on the GPS receiver in the field as long as you've got a real-time differential correction source. Examples of real-time differential correction are the beacon differential correction or the WAS real-time differential correction. The second type of differential correction is termed post-processing, and this type of differential correction is typically or is always done back in the office once you've brought your data from the field, brought it onto your desktop PC, and then use desktop tools to perform post-processed differential correction. Ken from Albany asks, how would Trimble's GPS Correct post-processing change the ArcPad data check-in process into ArcMap? If you are using Trimble GPS receivers and the Trimble GPS Correct extension for ArcPad, this GPS Correct extension collects all the information that is needed for post-processing back in the office. GPS Correct does not do any post-processing. Once you are back in the office and you wish to do post-processing, you need to add an additional step before you actually check in your data into your geodatabase. Using Trimble's GPS Analyst extension to ArcMap, you would first post-process your data collected in ArcPad, and then once you've done that, you'll update your data in the geodatabase. The next question comes from David in Tampa. If using ArcPad on a Windows mobile device with a GPS receiver, can it automatically store the walking path in addition to points that may be added in the field? Yes, it can. ArcPad, irrespective of what device you're running it on, has support for a GPS trail log or a breadcrumb trail that you can have active at any time, and simultaneously to capturing features for your shapefiles, this track log can store information at the frequency that you specify as you're walking along. This track log is actually saved in a point shapefile. So at any point, you can actually take this point shapefile and load it into your desktop GIS system and use that to view the track log or the points of where you've walked. Ken from Albany asks, if data is created in ArcPad while in the field, can that data then be checked back into ArcMap using the check-in function? I presume what's meant here is while you are in the field, can you check that data back in? And the answer is not really. You need to connect your data or your mobile device to the PC that you use to check out your data, move the data from your mobile device to that PC, and at that point, that data is available for checking in and updating your geodatabase. Miguel from Island View asks, are there significant differences between ArcPad Application Builder versus 603 and 7.0? And the answer is yes, there are numerous differences between these different versions of ArcPad Application Builder. If you're using ArcPad 7, then you need to use ArcPad Application Builder 7.0. ArcPad Application Builder 603 is not supported by ArcPad 7.0. What are these differences? They take advantage of a whole range of improvements in functionality and customization that are included with ArcPad 7. For more details on these, you can go to our website, and there's more information is posted there. Brent from Richmond Hill asks, is it possible to select multiple features in ArcPad at the same time in both the handheld and the desktop? And the answer is no, that is not supported in ArcPad. In ArcPad, you can only select a single feature at a time. So that's all we've got time for. I will hand back to Jane.
Thank you, Shane. Before we say goodbye, I would like to point out some resources available to you. On ESI website, you can download at no cost the ArcPad evaluation software, which is a fully functional version of ArcPad 7 with a 20-minute timeout. There are also valuable ArcPad support resources available on ESI's support website with knowledge-based documents, user discussion forums, and downloadable software patches and utilities. The Arc scripts at arcscripts.esi.com is an online venue for sharing scripts designed to work with ESI software. Check under ArcPad for ArcPad-related scripts. If you are interested in learning more on ArcPad customization, we do have a Customizing ArcPad class available on ESI Virtual Campus site. Your comments help us improve our seminars. Please take a moment to complete our survey. Just click the Give Us Feedback link to take the survey. We hope you enjoyed today's seminar. On behalf of ESI, I would like to thank you all for attending.